We want to find the absolute and local maximum and minimum values of the given function. In this case, a function is given through a graph like this. This is a sketch of the graph given in the textbook, but we have preserved the essential properties of the function. So we have those uh, open red circles and others like I'm talking about this one here. This is an open red circle. This is an open red circle. This is an open red circle. That means that the points corresponding there are not included in the graph. But when we have a field red circle like this, then we know, like this one I'm talking about, that the corresponding point is inside or is part of the graph. That's the way of saying that graphically. So we have those points there, and with that we want to find the absolute extreme of the function, and the local maximum minimum. So let's start, as always, with the absolute extremes, which are essentially uh, easy to find. So let's talk about the absolute maximum value. And when we talk about that, we are saying at the same time at which point that absolute maximum occurs. And in this case, we get to look at the entire domain. In this case, we can say the domain is the interval from 0, close in 0 because 0 has image 2, because this dot here, this circle is filled with red. So meaning that the point is part of the graph. So the image 0 is 2. Let's call this function f. I haven't said. Let's call it f. So the domain goes from 0 all the way through 7, but 7 is open. So we can write here the domain of f is the interval from 0, close at 0, but open at 7. And that's why, because the red circle here is not filled with red, that is open, meaning that the point is not included in the graph. That's very important. That makes a huge difference. Okay, that and all the points between 0 and 7, including 0 only, have an image. For example, the image of 1 is 3. The thing is that is extracted or separated from the line that has a trend here. This red line has a trend coming from the left and then continues from the right, but that specific point at 1, the image has been extracted. We were expecting 4, but it was uh, got out of the trend of the line and put at height 3. That is, the image of 1 is 3 now in this graph. And what happened at 6 is that from the left, the graph stopped here, including the point, and continues then at this point, but not including the point, because the number 6 got to have only one image, can have two images, because in that case we won't have a function. So this is the situation here a little bit. And then with that in mind, we look at the whole domain that is from 0 to 7, including 0 but not 7, to find the absolute maximum value. And in this case would be the highest value or the largest value of f possible. In this case, we can see that that happens at 4 and the value is 5, corresponding to, in the graph, to this point here. So the absolute maximum value is f at 4, which is equal to 5. So the absolute maximum value is 5, and it's attained, or of course, at x equals 4. Now let's talk about the absolute minimum. In this case, we expected this to be this, as the graphic suggests, is the lowest value of, lowest point in the graph, that is the smallest value of the function. But the problem here is that the point here is not included. 7 is not in the domain, so um, we can say that the function decreases all the time, getting near 7, but never reaches an image at that point. And for that reason, there is no absolute minimum value for this function. So this absolute minimum does not exist. And that's very important to understand. The only way that this absolute minimum be 1 at 7 is that we include the point to the graph. That is, if we do something like this, including the point. But that, because we don't have that, that is, the point is excluded explicitly by not filling the circle, we can say that there is no lowest possible value to the graph, or equivalently, absolute minimum value for this function does not exist. Now let's talk about local, for example, local maximum. So the local maximum of this function is, for example, at 4. That is, at 4, this point here is at the global or absolute maximum as we saw here, but it's also a local maximum, because if we look close or near the value 4 here, that is, we look only at a portion of the graph here, the function, we see that in effect, again, the highest value of the largest value of the function is 5, attained at 4. So at 4 we have a local maximum. But there is another one. Let's say at 6 we have again local maximum. If at 6, and the image of 6 is 4, because that value is included in the graph, because we have the field circle here. So the image of 6 is 4, and that's a local, let's say this point. Sorry, I wanted to remark the point in green. And if we look close to 6, or near 6, we can see that the largest image or value of the function is effectively 4 at 6. So this is a local maximum. Okay? And there are no more local maximum, because at 1 happens another thing that we're going to talk right now. So first, let's go to the local minimum now. Local minimum. And we can see that the local minimum, let's put it in blue, we have 1 here, because if we look around 5, close to 5, we can see that the smallest value of the function is the image at 5 precisely, which is 3. So there's a local minimum f at 5 equals 3. But there is another one. Um, Here, let's say this point, let's put it in blue. Around this point, there is a local minimum. If you look close to value 2, we have local minimum. That in that case, we gotta talk about um, local minima. Okay, let's put it uh, back here. And above was also, there are two values, so we can talk about local maxima. F4, f of 4 equal 5 and f6 equal 4. And local minima is f of 5 equal 3. We have another one at 2. F at 2 equal 2. And at 1, the image of 1 is 3 because the point is put apart the triangle line, that is, this point here is not included in the graph, but the point is has been put here, down here. And then what we are saying is that we look close to 1, and in this case, remember, it is important to look close to the point. We don't need to go uh, far from the point. We always got to be or think near the point. So if we look close to the number 1, we can see that the graph is something like this, and the point, the separate point at 1, whose image is 3. So we can say that looking closely to 1, the value f at 1 equal 3 is the local minimum. So we got to put it in the local minimum list. So we have f of 6, f at 5 equal 3, local minimum. Same thing for f at 2, local minimum, and f at 1 equal 3. So we have 3 local minimum and 2 local maximum. And of course, we have an absolute maximum value, f at 4 equals 5, and there is no absolute minimum value of the function because 7 is not included in the domain.